No? 35. We'll get through this pretty quick. I believe so. Find the length of the arc. We said that yesterday S equaled theta over 360 times 2 pi r if you're in degrees, or S equals, you remember the other one if you're in radians? That's right, r theta. That was weak. All right. Find the length of the arc that subtends a given angle on the circle of diameter d. All right, so this is for part A. Is theta in degrees or radians? S equals 50 over 360 times 2 pi times 8 meters. That wasn't so difficult.
I didn't know what to do.
You put it into the equation?
I know, but
There's nothing to get. That's it. Part B, find the area. Yesterday we had two area equations for part B. For part B, we said the area equaled theta over 360 times pi r squared if you're in degrees. If you're in radians, it is 1/2 r squared theta. And I said all four of those should go on your note card. That way you can reference them quickly throughout the homework and learn them, and we'll move on. Okay? So to find the area, I'll use the degree one. I'll do 50 over 360 times pi times 8 squared. That's the answer for part B. You punch it out, get your answer. This answer is going to be in meters. This answer is going to be in square meters. Okay? Anything else? Josie? I can try. 39. Measuring two angles. If you look at 37. If A and B are 500 miles apart, if this is 500, express the angle ACB in radians and degrees. They must give you the radius of the Earth somewhere. If the diameter of the Earth is 8,000, that means the radius is 4,000. Right? 4,000 miles. So, to find in 37, to find the angle theta, you would have, this is 500 miles, right? You'd have 500 equals r 4,000 times theta. That's in radians. Okay? The distance, it says that's the radius of the Earth. AC. C is at the center of the Earth. A is on the Earth's surface. B is on the Earth's surface.
What does it do with the edge?
That's how you drive on the Earth, is on the edge. You don't go through the core.
No, but...
Okay, let's look at the diagram this way. You're at the center of the Earth. 4,000 miles up from the center is point B. 4,000 miles up is point A. When you drive, you're driving actually in a small arc that's 500 miles. Is there any reason why you guys want to be on my recording besides me explaining how to do this problem? Thanks. All right, we're moving on. Theta. You take 4,000 into 500 because it's 4,000. Theta equals 500. So you divide, and you get 1/8, don't you? So theta in radians equals 1/8. How do you change that to degrees? You take and divide by 4,000. How do you change it to degrees? Yep. You have 1 over 8, so you multiply by 180 over pi. That gives you a solution for 39. Okay? Perfect. Anything else? Yeah, I just did. Alex, you remember your test score you got the last time? You're the only person that I saw a news story of this. You're the only person, now they gave that a name, that exercise a name, they call it super brain yoga.
I'm the only one that did a brain break.
Yeah, before the test.
Marissa did.
I did too.
I didn't see you doing it.
We did it together.
Oh. And Logan didn't do it.
No.
Interesting results on the SCOTUS. And Logan didn't do it. All right. Anyway, they say now they're doing it, and there's a group of kids doing it now every morning as part of their calisthenics routine. And that's the only thing that they've been able to show an increase in intelligence. They've tried everything.
Wait, so what problem did you have to get to?
45, 47, I think, 45.
We only went to 42.
Yeah. So I said 43 or 45. All right, anything else? Great. I think it's time to move on.
We have a soccer family day?
I don't know. It depends. It's homeroom, and I got to get through trig functions because we have a worksheet coming up. Okay?
So what kind of worksheet?
All right. Now, let me go back and explain a couple things about how graphs work with angles. Angles we are measuring in two ways, in degrees and in radians. Okay? On your unit circle, you have angles measured in degrees, and you have them measured in radians. So far, so good? You have angles measured in degrees, and you have angles measured in radians, 3 pi over 4. Okay? The problem is that takes care of the trigonometric and the angles. The trigonometric part is when you have a point on the unit circle, the x-coordinate and the y-coordinate represent trig ratios. I don't know, do you remember your trig ratios? The trig ratios, 3 of them are the sine of theta equals the opposite over the hypotenuse. Okay, do you remember that? And on the unit circle, it equals the, which one, x or y? Y-coordinate. Okay? Right. The SOHCAHTOA is for the first one. The unit circle, x is the cosine of theta, y is the sine of theta. R is equal to 1. Okay? And we also had that, this. A lot of people put this on their note card. A lot of people put the cosine, the sine, x, y, and r. Those are all angles of trig functions. Okay? The problem is if we want to make a trig function map, that's a little different. A map means it has to pass a vertical line test. The unit circle doesn't pass a vertical line test so much, does it? Doesn't pass it at all. So if we want to do the sine of theta, that equals y1, and we will make a graph, we're not going to make a circle. We're going to make a picture that looks like, say, the absolute value, or say like the square root, or say like x squared. We have to be able to graph it out. And to do any trig function, okay, we have 5 critical points. Okay? Now, we have all this that we have to work on together. So don't think that we did it all in September. We only did a small piece of it in September. Okay? We only did a little bit of it. We have a lot further to go with this topic. Okay? So when we use a calculator, make sure you have yours out. When we go to degrees, when we go to radians, make sure you keep up. Because you're going to get kind of confused between unit circles and graphs. Why the difference? Well, one passes the vertical line test, one doesn't. That's the first obvious choice. One is always in radians. The other one can be in radians or degrees. That's the next obvious choice. Okay? These graphs down here are always going to be in radians. The graph on the unit circle, you can be in both. Okay? Does that make sense? Fantastic. So, we're set for a great section. We're going to do some identities. We're going to talk about some unit circles, some graphs, some points, and some definitions. Okay? Hopefully you remember a little bit about September as we move on. We just talked about that this was off the unit circle. These are our definitions. SOHCAHTOA, they come from theta. They come from the opposite side, the adjacent side, and the hypotenuse. Okay? You should have these not necessarily written down somewhere, But you should have a catchphrase or something written down somewhere. Opposite over hypotenuse, adjacent over opposite, or hypotenuse, and opposite over adjacent. Also on your note card, you have what's known as the reciprocal definitions. Okay? Cosecant is hypotenuse over opposite. Do you remember how we defined it in September? Cosecant was also what? 1 over sine. We also said that cosecant equal 1 over sine of theta. And we also said cosecant equals hypotenuse over opposite. We also said cosecant equals 1 over y if you're on the unit circle. We had all those definitions for cosecant. It depends where you're looking at to find your answer. Okay? So besides the green box, there's other definitions you have to know. What would secant be? If I ask the definitions for secant. Secant of theta equals what? Yeah, it equals hypotenuse over adjacent. It also equals 1 over cosine. And it also equals 1 over x. It depends where you're looking and what you're working with to know which one it is. But you have to know all three. Okay? And obviously for cotangent, that'd be the similar. That'd be adjacent over opposite. That would be 1 over tangent. And that would be x over y. Okay? Pretty good? So you have to know all those definitions, just not the basic green square variety definitions. Okay? On the unit circle, this triangle isn't just hypotenuse, adjacent, and opposite. On the unit circle, this triangle is x, y, and 1. Here is x, here is y. Okay? And the origin is right here, the origin. So there's two triangles that we use for our definitions. And we're going to add to that a third definition using a graph, but that's later. Okay? So far so good. I'm getting kind of excited. It's going to be a good worksheet when it comes around. It's going to be fun. Nice. Are you ready? Let's move on to some questions. Do you remember that in pi over 6, do you remember what your 30-degree reference triangle looked like? 30 degrees. What was our reference triangle for 30 degrees? I call him the spirit of 7th hour for this question, Ian Eidelman. 30 degrees, how do you label the sides? Must be something about the chair.
Yeah, I'm probably need that back.
Right, and what numbers do we put in for the adjacent, hypotenuse, and opposite? Numbers, those are variables. Numbers.
Square root of 3 over 2 is your x, right?
Close. Square root of 3 is in there. 1's in there. 2's in there. 1 is the short leg. Square root of 3 is the long leg. And 2 is the hypotenuse. Is that on the unit circle, that triangle? No, because the hypotenuse isn't 1. What was your reference triangle for 45, 45, 90? 1, 1, square root of 2. Some people actually put those on their note card as well because they come up a lot in calculus and business calculus. Now, it says in radians and in degrees, it's 30 degrees and pi over 6. We said there was a variety of ways of doing that. You could go to the unit circle, you could draw a 30-degree angle, you could drop down this other leg, and you can put in the 1, 2, and square root of 3. And you can see that the sine is the opposite over the hypotenuse, which is 1/2. You can see the cosine is the adjacent over hypotenuse, which is square root of 3 over 2. So on and so forth. You can keep going on down the line using your definitions. We said on the unit circle, we can take these definitions, and we can go to someplace like pi over 6. And use the coordinates, because the hypotenuse is 1, we can say this is square root of 3 over 2. We can say this is 1/2. We can say the cosine is the x-coordinate, which is square root of 3 over 2. The sine is the y-coordinate, which we can say is 1/2. Tangent, cotangent, all those could be using x and y definitions. Okay? So there's a lot of ways of doing these problems. You can draw them out. Some people punch them out and memorize the decimals. Some people just take 180, put it in for pi, divide it by, get 30, and think of their favorite reference triangle. Lots of ways of doing these problems. I'm not going to say you have to do them one way, but you have to find ways that you can answer them all correctly. Okay? 45 degrees. What's the tangent of 45 degrees? Well, it depends on how you're going to do it. If you're going to look at this triangle up here, it's going to be the opposite of the adjacent, 1 over 1. You're in good shape, it's 1. If you're going to go to the unit circle, you go to pi over 4, you have root 2 over 2, root 2 over 2. You take y divided by x, and you get 1. So that is your ratio. But make no mistake about it. The question is, you have a trig function with an angle that equals a ratio. Okay? You have some trig function, you put an angle into it, and you get out a ratio. Okay? Here's your angles, here are your ratios. Don't forget the fact. Huh? That should be in your unit circle. Okay? You should have at least this much information on your unit circle. So if I ask, say, who can I call on? Josie. If I say, what is the sine of 210, she should be able to tell me what the sine of 210 is. Which is what? Quiet. Alex, you're throwing off her mojo.
Negative root of 2.
Close.
Or is it the other one?
It's the other one. Which is what? Negative 1/2. So I said here's 210 right here. All the way around 210. What's the reference angle for 210, Courtney? You do so. You didn't even think about it. How far is it from this to here? Yeah, this is 180. 30. How do you label a 30-degree reference triangle? I call the spirit of 7th hour for this one. Close. In the third quadrant, it would be -1, negative root 3, and 2. So the sine is...
Why is that positive, too?
Because hypotenuse can never be negative until I tell you different. Yeah.
Everything else is negative.
I said x and y have to be positive and negative because a point in the third quadrant has a negative x and a negative y. Yeah. Sine of theta is opposite over hypotenuse. Or Josie looked on her unit circle at 210, saw these 2 points, negative root 3 over 2, negative 1/2. She picked this one, which is the cosine. I clearly asked for sine because I can play back the recording, and the answer is going to be negative 1/2. Okay? A lot of you have to get busy with this and learn it instead of just sitting back doing nothing with it. It's not going to come to you. You're going to have to study this and use it, and that's why a note card is the best choice. Okay? It's a quick reference on how to do these questions. That should take you less than 2 seconds every time you're faced with one. Okay? It's going to take some time. All right? But your reward is, I mean, if you qualify, you only have to do this once instead of possibly doing it twice. All right? So there's the information. There's the results, the ratios, the angles, multiple ways of doing it. There's our reciprocal identities that I said should be on your note card. There's your, I call them quotient identities, which should be on your note card. Okay? So you should have those 5 on your note card. If you don't have them in your note card, I will not feel a bit sorry for you next week when we start doing assignments. Now, the big 3 in terms of Pythagorean identities. Okay? These are crucial. Very crucial. I want you to know something about identities. I could ask you a question right now, but you wouldn't know the answer. So instead, I would ask a question, somebody would think they would know the answer, but they would be wrong. There are actually 1, 2, 3, 4, 5, 6, 7, 8. There are actually, you're writing down 8 identities. There's actually 24 different forms of those identities that you can write on a note card, but that'd be redundant and silly. So instead, for every 1 identity, you actually have 3 identities you can use in your work. Okay? For every 1, you actually have 3 that you can use. For instance, I'll choose a safe one. The cosecant of theta equals 1 over sine of theta. Yes, Stephen?
Would you put those Pythagorean identities?
Oh, yeah, those huge. Yeah. The cosecant of theta equals 1 over sine. That's 1. An offshoot of this would be that cosecant of theta times sine of theta equals 1. You see how that's a rewrite of this one? And finally, you can rewrite it as the sine of theta equals 1 over the cosecant of theta. You have to be very well versed in the fact that you can rewrite identities that look different but all mean the same thing, because you're going to have to use them, a lot of them. Okay? The Pythagorean identities, I'll talk a little bit about that, where they come from and what they mean. Okay? It goes back to our pictures. We said that we had the hypotenuse, the opposite, and the adjacent for theta, right? And we said on the unit circle we had the 1, the y, and the x, correct? So far so good. We also said we have x squared plus y squared equals 1, correct? What trig ratio goes in place of x? Courtney. What trig ratio goes in place of x? Look back in your notes. X equals what trig ratio on the unit circle? Cosine. Y equals sine. So this means that you can have cosine squared of theta plus sine squared of theta equals 1. That's why it's known as a Pythagorean identity. It comes from the right triangle and comes from your substitution. You can write 1 squared if you like, but that would be silly. Okay? Now, yep, x equals cosine, y is sine. If you have this written down, this picture and that identity, you're in great shape. Now look at the other identity I could have. I could have that cosine squared of theta equals 1 minus sine squared of theta. I could also have sine squared of theta equals 1 minus cosine squared of theta. I can rewrite that 3 different ways and get 3 different looking identities that all mean the same thing. Interesting. I could do that. Oh, what if I took this identity and divided every single term by sine squared? What is sine squared over sine squared going to be? 1. What is cosine squared over sine squared going to be? Yeah, what does it equal? Cotangent squared. People just wrote this down without even reading it. Do you believe that? I do too. I've seen it before. If you put a squared here and a squared here, wouldn't you obligated to put a squared there?
Yeah.
Yeah. What is 1 over sine squared equal?
The cosecant
Squared. That's where this identity comes from. They divide everything by sine squared. What do you think you divide this one by to get this identity?
I don't know.
I don't know what we're talking about.
Yeah, me neither.
Cosecant squared.
I don't know.
That's because you guys checked out and I was still talking. I didn't say it's time to check out yet.
I was writing.
Oh, jeez. All right. So, on here, we have where y, x, and r. Where do they come from? Y, x, and r. Where do they come from? Radius, opposite side, adjacent side, On the coordinate axis? We talked about that. Good. So r equals the square root of x squared plus y squared. All right. X equals which trig function? Let's see. Stephen. X equals which trig function? So I can write this, cosine square root of theta plus sine square root of theta. I can write that into there. The one thing that you missed on the last slide is all the intricate relationships between all those identities. They all work together. Nothing is separate. It all moves together. So for you just to try to isolate one and learn it, it's not going to work. They all go together as one big idea. Okay? So here are some definitions. Y over R, have you seen that definition before anywhere? Yeah, you put it on your note card already. What is R in the unit circle? And what's the length of it? 1. So sine of theta equals Y. Have you seen that before? Cosine of theta equals X. Those answering no, you wasted 20 minutes already today. Let's try not to wait the last 20 minutes. Cosine of theta equals X over R. If R is 1, what does cosine of theta equal? X. What's tangent equal? Y over X. What happened to the opposite and the adjacent and the hypotenuse you were talking about? I just said they're all one idea. They're there. This is the opposite side, this is the adjacent side, and this is the hypotenuse. R is equal to 1 on the unit circle. You're trying to make everything independent, and it's not. It's one whole thing. That's why you're having problems understanding it. You're trying to memorize each part, and it doesn't work that way. It's the whole picture. It's all of it together. That's how it works. So you can't just look at it for a minute and think you have it, because you don't. So, the secant. Does it make sense that secant is R over X? Yeah, because it's the reciprocal of cosine. Or it's the hypotenuse over the adjacent. Or it's, 1 over cosine. Is this sinking into at least one person? All right, I got 2 head bobs. That's good enough for me. You ready to move on? I'm not sure if I like you here over my right shoulder, but we'll give it a go. Now, I'll try to do this slowly. This is quadrant number 1. This is quadrant number... You do?
I know that.
Great. Now, quadrant number 1 is also known as the A quadrant. Quadrant number 2 is also known as the S quadrant. Quadrant 3 also known as the T quadrant. And quadrant 4 is known as the C quadrant. Why? Those are where the trig ratios... What's this mean, this symbol? No! That's what it says. What does it mean? I thought we were way past that. Positive. This is where the trig ratios are positive. ACT is super. In this angle, if theta starts here at 0, ends in this angle right here, which trig function will have a positive ratio? Sine, cosine, or tangent? Cosine. What is the cosine of 300 degrees? That's the ratio, 1/2. Cosine's the x, sine's the y. Also, what's the reference angle from here to here? What's the reference angle going to be? 60. How do I label this triangle? Where's the 1 go? On the x or the y? 1's the short leg. Where does it go? It goes on the x, opposite of 30. Where's the square root of 3 go? And the 2 goes right here. So, cosine is adjacent or hypotenuse, which is 1/2. If you look on the unit circle, you have a point, 1/2, and negative square root of 3 over 2. You pick the 1/2 for your answer. Okay? If you have nothing to do with study hall, get out your unit circle and look at it and figure it out. If you have nothing to do with study hall, get out your identities and look at them and read them because you're going to have to know them quickly. Okay? You're going to have to know how they work. Because we're going to write proofs next week. Straight up, that's what you're going to do. If you think that's too hard to do, you can download this weekend and take a look at it if you like. It's there. But I already see some people rolling their eyes. That means it's time to move on. So right here, find the values of the 6 trigonometric functions. I said last time when it says 6, all you have to put down is 3 and rotate them each time. This time I'll take the sine of theta, cosine of theta, and the tangent of theta. Be very careful you do not know the answer to this question. Before, when it says r equal the square root of x squared plus y squared, do you understand that came from the Pythagorean theorem? Okay. This missing side is not b. That was in geometry. They gave you a, b, and c. This is trigonometry. They don't give you a, b, and c as a simple way out. This side actually has a length of, is it the difference between the hypotenuse and the leg squared, or is it the sum of the legs squared? Do you subtract to find that leg, or do you add to find that leg? What are you talking about? Let's say in geometry it was b. You would say a squared plus b squared equals c squared, right? What does plain old-fashioned b equal by itself? What does b equal? C squared minus a squared and not divided by square root c squared minus a squared. That's what this is. B, the missing side, is a square root of c squared minus a squared. Where's theta? In the top of the triangle. What's the opposite side going to be? The square root of c squared minus a squared. And what's the hypotenuse going to be? C. It's not good enough just to write this down for notes. You have to know where it comes from. What's the cosine of theta going to be? What's the adjacent side? A. What's the hypotenuse? C. A over C. What is the tangent going to be? Yeah, my pen hit a bad spot. Square root of c squared minus a squared all over a. And that's your final answer. Okay? You can't use b, you have to use the radicals. If you take a look at the inside cover of a calculus book, you'll see these definitions on the inside cover. Okay? That's why it's called pre-calculus. You find out where they come from, then you use them later in another textbook. Okay? Ready to move on? Perfect. I'm going to hit this right here. Find the exact values of x and y. I call them the spirit of 7th hour. I know. 10? Sorry, not 10. How do I label a 30, 60, 90? 30, 60, 90. 2's the hypotenuse. And the long leg is, see, you're throwing your voice. That's a great trait to have. Ian thinks it, somebody else says it. That's amazing. So what's x going to equal if you look at the ratios? 5. What's y going to equal? How's y? What's y going to equal? 5 root 3. The short leg is equal to half the hypotenuse. The long leg is equal to root 3 times the short leg. So I find the short leg by taking the hypotenuse in half. I find the long leg by multiplying it by root 3. We'll stop there. So try to get through, what, 15? 1 through 15 odd? Okay? That was fun today. I don't know that page.